CH3 fine. So, you get this product. Now, this can cyclize, just write the product. Just I want to know how you can write it, because looks to be simple. Write it by yourself, write the product now. Finished. Yes, you got this product, right? Yes. Yeah, if I have an, you can get it, but we will see that in the another, because next reaction we are going to see additions. There we can work on it. So, we will go slowly now, alpha cleavage, then intramolecular, then we will go to addition. Yeah. Always you have a chance to do it. Yes, we will now go into another nice example which you will like to do. Sort of diketone, right? So, if I photolyze, yeah, you know it can be S1 or T1, that is fine. Now, what happens? I can excite one of my ketone, right. So, it can go to O dot. So, which will be the hydrogen it will try to abstract. So, now I have given it two options alpha, beta, gamma, right, or I can write alpha, beta, gamma. So, it has an hydrogen here to abstract, it has an hydrogen here to abstract. So, we can call this as A, this as B. Which you think this, just you have to think little bit on the molar structure, because it is a type of, how many carbon it is? No, system 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, type of 10 member ring system, right. So, you have to just think about the model 10 member ring system, how like I want you to even do this model. You can try doing this model and see which hydrogen is near to this carbon here. If you can remember, it is fine. If you can visualize that, it is fine. Otherwise, just try to do a model, nothing wrong in it. It takes only hardly like few minutes. You can do the model and think which carbonyl is near to it. Any idea if you can visualize which hydrogen should be near to this carbonyl? Yeah. So, this hydrogen is nearer to your carbonyl than this, okay, this part, fine. So, now then you abstract the hydrogen. So, what you are getting it? So, you get a 1,4 diradical. Now you guys have to tell me what this 1,4 diradical can do. Looks to be like yeah, but it is 10 member ring. You have studied little bit. Just for my clarity, I will write one more time. You just think on. You just let me know what it can do, so that I can just follow. Cyclization. See, only two you can write. One you can write cyclization, or you should write Norris type 2. Norris type 2, can you think about here? No. If you write cyclization, what you get? Very good. It's possible, na? Yeah. Then write the structure. We'll see. We'll see both the ways. Just write it by yourself without seeing others, whether you can think about that 8 member and 4 member. Getting like this. Right. So, I will just cyclize this part with an OH here and carbon. You might get in the down with the OH and carbon, both are same. You think this structure is stable? See, one thing you have to always do remember, when you photolyze, okay, the product which are formed, it also can absorb light. Okay. Does not mean that once the product is formed, it will not absorb light, because it also has a ketone. It will also absorb the light, that also you should think, because once you start some reactions like Norris type 1, once you have a ketone, then it will do Norris type 2. So, you will have a continuation process. So, you have to keep on thinking. If this carbonyl now starts absorbing, then what you do? Because this also has a carbonyl, no? There is a carbonyl here. It is not going to say that I am not going to absorb light. Okay. So, if it absorbs, what you expect now? That is the interesting of this. You can think about alpha cleavage. What you get? You get a very nice product. That is why this reaction tries to go this way. Just think. Alpha cleavage, what then? Get your ketene back. I can just make my ketene from here. Okay, this reaction happens in light as well as heat. Okay, once I take this, okay, and keep it in the room temperature or for a higher temperature, just cleaves down to give me a nice, what member ring it is? 8 membered, that is cyclooctanone type of ketone, plus I get my ketene, and you know the ketene reacts in alcohol and give you other products, that is fine. See, this example is very important, that why I am saying do not stop with your one photo product. Okay. Once you should keep in mind that yes, my product can again absorb light. If it again absorbs, then any feasible reaction happens, whether I can do any alpha cleavage again. This all you should start thinking now. Done. So, we will go for next example. So, I am taking a type of dialdehyde system. Okay. And since I have not introduced aldehyde most of the time does the chemistry from singlet. Okay. It does not do much intersystem crossing, their energy gap is huge, they do not do intersystem crossing. So, you can see most of the time chemistry happening from the singlet state. Okay. So, once I photolyze, then it goes to singlet S1. So, can I write that singlet here properly? Now, what it can do? Does a very one simple thing, it just rotate here. Okay, just rotation happens. Okay, this part is it does this part, you know why, because you have an alpha, beta, gamma. Okay, alpha, you have an alpha, beta, gamma. So, so this O dot has to abstract this hydrogen. Okay, that is why it does this what do you call flipping to get you O dot. Now, it is as a vicinity to abstract this hydrogen. So, if it abstract, then what happens? Now, tell me what you are going to do. This part is little bit interesting if you can think. Can you think there? What makes this reaction to go forward? Cyclization. No, the next step. Which pushes this reaction to go forward? Because there are radicals. No? You are not pushing your radicals. That is why no, always when we have an aromatic ring, we never think there is an electrons there. Right. So, I can happily push like this. See, normally I also have that, I put like aromatic ring, we put always like electronic cloud, like we never put like a double bond like system. Yeah, it does this. So, why it has to do this? Just see the product, write the product. If you just write what product you get? Yes, you get a very nice intermediate ketene. That is why it does this. When you can ask that, sir, formation of an acyl radical, acyl I have a radical in acyl, all these things, because it wants to move towards ketene, it does this, because that is the formation of intermediates always keeps the reaction to move forward. Okay. Type of driving force, if you want to generate a carbon, reaction tries to move that direction, ketene. Yes. Now, you can finish it off. How ketene reacts? How ketene can react? Now it does not need radical, right? It is your simple chemistry. You can right. Then your minus can take this hydrogen, just 2 electron minus. Nice, right? Type of a photoenolization type of chemistry it is. So, that is why I am trying to do like different type of examples, so that you just get into it. See, once you get this dialkyl system, if someone gives you dialkyl system and says you want to do the photochemistry, you cannot, it is very hard to get into Norris type 2 unless you did this example. Otherwise, you will be looking for some other chemistry, like can I do alpha cleavage or can I do this chemistry. Okay. You cannot think about Norris type 2 that time, like intramolecular hydrogen abstraction can occur. This time we will take a simple ketone, okay, not with a big stain or anything. We will take a simple ketone. You have studied this ketone already, okay. Where you studied this one? You have studied this type of ketone. What it does? It undergoes a beta cleavage reaction. So, you have to now think about beta cleavage also in this process. Plus, you have to think now this chemistry can also Norris type 2 reaction or abstraction, Norris type 2 process can also happen here. Okay. So, now if I photolyze this one, you can say I will get S1 or T1 because it is an aliphatic ketone. Now, you have a methyl here, right. So, I can say it is alpha, beta and this is my gamma carbon. So, it can start abstracting hydrogen from there also, na? So, I get again 1, 2, 3, 4, 1 for diradical. Now, what you are going to think about? Whether it is cyclization, you are going to do a cyclization or you are going to do Norris type 2. You want to do Norris type 2 because the ring is stained. Want to cleave this. Sorry, I have missed one carbon. I will just do it one more time. I missed one of the carbon. So, I have a carbon here. So, I get a product like this. Now, let me know like whether cyclization, if it happens, you think like cyclization will not occur in this process. Is it a chance like this will be 80%, that will be 20%, or you are saying like no sir, this is the only dominating product, I do not get my cyclic product at all? Can be. Can you write the cyclic product, see whether it is favorable or not? Right, you get a cyclic product of this type. Possible or not? A straight statement, yes or no. Like you have a 5 membered with a followed by a 3 membered, it is not possible, right? Yeah. Fine. See, some cases why I am trying to draw this, in some cases you get cyclic products which are possible, okay, with a 4 membered coming out, or something like 6 membered with that 6 membered with 3 membered, if it comes out, then it is. When you see, you immediately you say that no, it is not possible, but just write the product. Sometime it will be a 6 membered followed by a 3 membered attached, that are possibles, okay. So, it is better to write that. Okay. Clear. So, we will take I think this example you should guide me, okay. I am just going to follow what you are telling me. Oh sorry, okay, fine, that is okay. Beta gamma. So, you know that it goes to S1 or S1 or T1, and from there I can get my hydrogen abstraction. See, I made this ketone in such a way, so you do not have a choice here alpha, beta, gamma, okay. Only choice you are left behind is alpha, beta, gamma. Now, you get me the, so you get a diradical, yes. Yes. Now, you help me out, what I have to do? You want to do a Norris type 2 reaction and Norris type 2, you want to cleave this one, to cleave this part and get you alkene. So, you should think like this way, okay. That is always better when you have a cyclic system. Please think in this direction. For just for simplicity, we are writing here in this way. Okay. Can I cyclize this? No, just I am asking. Can I cyclize? No. This molecule preferred to cyclize. Okay, we will try to cyclize this, see why it is happening, okay. Just cyclize this and see what you are going to get. Yeah, you will get a really, the way you look in the picture it should be like. Yes, sir. Yeah. So, that is why once you start thinking in that angle, you will know that why it is cyclizing. We always look like this one. So, so you get like this. Basically, compound is also not to be happy like sitting here. Compound says that I am not so happy to sit like this. Yeah, anyhow, I cyclize, it says that I am not happy. What it does, because now you can see here what is happening. Are you getting it? Try to understand. Now I have two ketones. Okay, I have used one of my ketone for doing Norrish type 2 reaction, or sorry, like hydrogen abstraction reaction. Now again I am left with one ketone down. Right? This can also absorb light, right? So if it absorb, what you can expect? Let's just think. You have now a ring strain one, a system like this. Very strained one you have, right? Nourish. So yeah, now I have a ketone which can abstract. Yeah, your Norrish type 1 alpha cleavage, right? Because you know that once you are strained having ring, you always prefer to do an alpha cleavage reaction. So if I do an alpha cleavage, right? I got this product. So this is your 1, 2, 3, 4, 5, 6. You get this diradical, right? So what we studied when we do an alpha cleavage reaction, you get this. What this radical does? You get an acyl and alkyl radical, right? Whenever you do an alpha cleavage reaction, what you studied there? One, it can recombine, okay, or it can decarbonylation can take place to get a cyclization, or it acyl radical can abstract an hydrogen, or your alkyl radical can abstract an iron. These are all possibilities we have studied. Which fits here? So I always said that it's nice to generate an intermediates, right? Most of the time, reaction likes to do. I can abstract this hydrogen, or I can abstract this hydrogen. If my acyl is going to abstract this hydrogen, I am again generating a double bond. If I abstract here, I am generating an ketene. So you prefer to do ketene. Not stereochemistry, just a single line. Okay. Now what happens? See, I generated a ketene. What do you think about? Come on, man! I have a OH here. I have, for you only, I have just put a non-bonded electron so that you get a feel. So this can attack, right? That is all. So, now the interesting point is that can you attack this and draw the structure? I can give you 2 minutes. Just it's your regular chemistry where you have like you can take this and you attack your thing like your regular one. I will give you the final product, okay. You just think how it comes. You can write and show to me. All right, all this can be either way. It should be a final product. Okay. Just I am just taking this part and now making a bridge here, and this will be my the cyclic system, and this will be my bridge 1. So, I am saying like when you go when you have any problems, they give this product and give you this one, that immediately doesn't strike on your mind. Okay. So, you have to think that first you do an intramolecular hydrogen abstraction and followed by your alpha cleavage reaction. Yeah, these are little bit tougher problems, but it is nice to work on this. Okay.
Sir, after first cyclization, when you done this alpha cleavage reaction, is it possible there was a gamma hydrogen abstraction?
Gamma hydrogen in alpha cleavage, after alpha cleavage.
In place of
Okay, you want to do this gamma hydrogen abstraction again from this one, right? You are talking
yes,
about
yes,
alpha, beta,
decide.
alpha, beta, alpha, beta. You want to pick this hydrogen. Yeah, but
Because if there is a Norris type reaction, this molecule is
yeah, once you pick this hydrogen, what happens after? Are you getting any products, good products?
If there is a Norris type 2 reaction, this the molecule product molecule is simply I, because there is only 6 member and a 4 member.
Yeah. What you can do, just write the product, okay, and we will discuss that. See, we will see the product first, but the reaction, these are like it happens might be because of your much ring strain. It wants to open up rather than doing your hydrogen abstraction. But anyhow, we will just write the product and we will see that also. Okay, nothing wrong with it. You just write the product. We will definitely discuss that. Are you getting the this product? Or you can at least imagine. That's good. Simple ketone. Okay. Only one thing I did, I am slowly involving a double bond into the system. I am taking an example in such a way that it is a ketone with as a gamma hydrogen, but slowly I am involving this double bond. I am thinking what this double bond can do now. You get S1, G1. So, up to this you can write nicely. So, alpha, beta, gamma, you have an hydrogen here. again it is sorry alpha beta, oh sorry, extremely sorry, I will take the another. Okay. Now I can take this hydrogen. Okay, I can take this hydrogen now, gamma out. OH, I will get a dot. Now what you can think about? Now again it's 1, 2, 3, 4 diradical. What this molecule can do? Any guess? It can do Norrish type 2. You want to do? You want to do a cyclization here. Okay. Okay. You, yeah. See, that's how it is. No? What it does is, I can write it another way, right? Similarly, you can write like this. It can be. I can write the same molecule. I can write this, no? The similarly. Yes. So now I can take this radical. So instead of doing the cyclization here, okay, I am trying to do my cyclization with this. You see. So that's why I just introduced the double bond to show you how we are involving the double bond. So what happens then? It's a very nice product. So these are like really nice examples where you can think about making molecules. I am going to give you two structures now. Okay. So there are two examples, same molecule. Okay. Okay. Now tell me, once I shine light, see both of them do their photochemistry. I am going to ask like which one will do hydrogen abstraction reaction? Which you prefer that it will do hydrogen abstraction, and from which? I will call this as A and B. I have two systems right now. Okay. So it should be A. Yeah, because you have an hydrogen here. That is why I said like that planar thing should be. Okay. In this case it is very, you cannot do that. Yeah? So, can we write the chemistry then from here? Like this photolysis, I get an S1, then it undergoes a nice intersystem processing. See, this undergoes nice intersystem processing, okay, because it is an aromatic type of ketone 2 triplet. Then I end up with a VH the dot here alpha beta gamma. So, you have a 1,4 diradical again. Now, we have to think what it will be doing. You want to carry out a cyclization reaction, or you want to carry out a Norris type 2? You want to carry out a Norris type 2. So, I can cleave my beta bond then. Product. So, I can write like this: phenyl carbonyl 1, 2, 3, 4. So, I get a product like this. Oh, sorry, I have missed my tertiary thing all the way around. Fine. Any idea what B can do? Can you B can do alpha cleavage? It's possible. Huh? So, see, that is what, like today, since I am taking hydrogen abstraction, I am concentrating only on A, right. Tomorrow, like if in future in any exam or anything, you are going to given A and B and find out the product of A as well as B. That time you should able to write both the products. You should figure out whether it is A or B which is giving out the product. Yes, sir. Yeah. So, what we will do is that since we have covered both of the reactions, just we will try to summarize, okay, these two reactions and see what we have learned so far, whether we can recollect what we have studied. I said that if you have a carbonyl system, okay, once I shine light I get a system like this, right. Then we discussed that which will be reactive. your C dot or your O dot. We said that O dot will be the reactive one, okay, because you get an alkoxy radical and your oxygen should be electronegative, does not want a radical on its side, but on the other angle your C dot radical is dispersed across your carbon and oxygen. So, that is why we said the N carbonyl chemistry, N pi star reactivity is dominated most of the time by your radical on your oxygen atom. That is the first thing. There are good reactions which is induced by your carbon radicals, that we will be seeing in your addition to alkenes. That will be the next reaction which we are going to see. Okay. This is alpha cleavage reaction, then we see intramolecular hydrogen abstraction, then we are going to see that reaction. Okay. In that case, there are examples where you can see C dot radicals initiating the reactions. Okay. So, that is what the first part we said, that in N pi star your O dot radical is going to dominate. Okay. Then we studied it does 5 reactions, 5 chemistry you can see. What are they? One we said it is cleavage, then hydrogen abstraction, then what we said, addition to pi system, right. Then that is addition to pi system where you do cyclization. Then are we recollecting? That is what I want to see. No, the chemistry. One we said there are 5 chemistry we said we have to deal with. One we said we have to study cleavage, then we said we have to study hydrogen abstraction reactions, addition to pi system, then recombination all is about the radical. Na? This is your chemistry N pi star reactivity. What are the reaction of N pi star? Electron transfer, right. So, it has nice electron transfer reactions. Just study about them, then we will be studying energy transfer. See, these are the 5 chemistry we said na, initially. When we take a carbonyl, excite a carbonyl, it comes to your N pi star reactivity, and we say that O dot will be the reactive species, and there are 5 chemistry we can observe in N pi star reactivity. One is cleavage, hydrogen abstraction, addition to pi system, electron transfer reaction, and your energy transfer reactions. Fine. So, in that we started what? First we said we will do one by one. Initially we took cleavage reaction. Okay. So, cleavage we said that we are going to study 2 types of cleavage. One is alpha, another is beta cleavage. Okay. In alpha cleavage, what how we divided? We divided 3 systems there. We saw 3 systems. What are they? No, the systems. We work with saturated acyclic ketones, then we work with saturated cyclic ketones, then we work with beta gamma unsaturated. That is how we carried out. Right now, that is how we are moving on. In saturated, how we worked? Again, in saturated, we saw like 3 good divisions. a type of symmetrical ketone where your carbonyl on your both sides, where your carbonyl both sides are symmetrical. Yeah, we have like both sides symmetrical ketone. We took and we studied this chemistry. Then we took a carbonyl where both sides are different, right. Then we took a carbonyl which has a hydrogen in the beta position, right. There only we saw like reactions like intramolecular hydrogen abstraction happening. So, these are the 3 ketones we worked on. Then in saturated cyclic system we worked on 6 membered ring system, then we worked on 5 membered, we worked on 4 membered ring systems. Right. Then in each ring system then we saw like one can generate 1,5 diradical, another generates 1,4 diradical and your 4 member generates 1,3 diradical. Then we worked with our beta gamma unsaturated systems. In beta cleavage, what we did in beta cleavage? We took like 2 type of examples, a carbonyl like having a cyclopropyl system, a carbonyl system having a cyclopropyl, we dealt with that. Then we dealt a carbonyl system having a epoxy systems, right, and we said that epoxy system should go only from singlet chemistry. So, that is how we saw our cleavage reactions. Yeah. We started working like this only in our cleavage reactions. Once we finish cleavage reaction, now we start with our hydrogen abstraction. In hydrogen abstraction, now we are initially doing our intramolecular hydrogen abstraction. Next class, particularly we are working only on gamma hydrogen abstraction. Next class I will teach you beta, some other distance hydrogen abstraction. Then we will do intermolecular hydrogen abstraction. Then we will finish hydrogen abstraction. Okay. After that, we will go to the third reaction, which is addition to pi system. Clear? Okay. With this, we will end our class.